एक्चुअली एनोमलस में वीक होता है.
Or apart from the magnetic field difference, is there anything else also?
In anomalies, spin is zero. Spin is not zero, while in normal Zeeman, it is the spin is zero.
Like spin consideration, like happens in anomalous, and there is no spin consideration in a normal. Okay, so basically, सही बोला है कुछ हद तक, क्योंकि ज़ीमैन इफेक्ट सबसे पहले जो ऑब्जर्व किया गया था जब थ्री मैग्नेटिक लाइंस हमें मिला था. और बेसिक क्या है इसका कि जैसे ही हम एक हाइड्रोजन एटम को लेट्स से तो हमने एक्सटर्नल मैग्नेटिक फील्ड ऑफ सर्टेन स्ट्रेंथ में उसको रिप्लेस किया, then you will see instead of one line we will get three lines due to the external magnetic field. Now why it is so? That was the question. Then we thought since electron is the main, like we are getting this spectrum, means that there are splitting of energy levels in the electronic orbitals. Because electrons are jumping up and down, so these transitions are occurring from the electrons, not from the nucleus, because we know nucleus are more stationary. Therefore, we thought, the scientists at that moment thought that there must be some splitting in the electronic energy level is happening, so that the transition is coming in the other states and we are getting extra line. ठीक है, ये समझ आया?
मैम रिपीट करोगे एक बार?
हाँ, जैसे कि आप देखो, लेट्स से हमने एक हाइड्रोजन एटम को एक्सटर्नल मैग्नेटिक फील्ड में प्लेस किया, ठीक है. Then we see that instead, if the magnetic field is off, there is one line, and if the magnetic field is on, there are three lines. Now we have to think where these three lines are coming. Like this one line is a transition from one electronic energy level, let's say n जो है n value 3 से n value 2 में आ गया, तो हमें एक एनर्जी लेवल मिलेगा, तो इसलिए हमें एक ट्रांजिशन मिल रहा है. अब न्यूक्लियस तो स्टेशनरी है, तो ट्रांजिशन किसकी हो रही है? इलेक्ट्रॉन्स की. मतलब दे आर jumping to higher state and or they are coming back to the like ground state. That's why we get lines in the spectra. And now if we have more lines, means they are splitting in the energy level itself, so that the electrons from a higher state, it can come to another state and we will get another line, right? Or extra lines because of the multiple energy levels inside the one energy level. ये समझ आया?
यस मैम.
तो सबसे पहले तो ये था, समझ आया कि चलो जो हम एक एनर्जी लेवल कह रहे हैं अभी without magnetic field, it is not actually one electronic energy level when the magnetic field is on. Therefore, more lines means there are more energy levels and they are coming from the same values, means the energy levels are splitting. And now, then we have to think that how this splitting of energy levels we can explain. Therefore, they thought, let's say electron is a tiny magnet because it has a charge and it is revolving around the orbit. So it will act as a magnet. And it has associated spin angular momentum. And now if we have a, orbital angular momentum, because we are talking about just normal Zeeman effect, means we don't know about spin anything till now. We just thought electron is a magnet because it is electron that has a charge and it is revolving around the nucleus. Therefore, the charged particle is revolving, so it has associated magnetic moment, which is named as orbital angular moment or orbital angular magnetic moment. And then we thought if a magnet is placed in an external magnetic field, then there should be interaction. And now this interaction is there is a change in the energy level. And last, what will be the change? That is minus mu dot B. While B is the external magnetic field and mu is the magnetic moment of the electron. And if you see this magnetic dipole moment associated with the orbital angular momentum of the electron, then we get minus mu orbital. We know that minus E by twice E into L. This is for electron. So we can place this mu with the substitute this value of mu here in the potential energy or change in potential energy, and we will get this term which is dependent on ml values. And this ml is quite important because this is the key changing factor here, because ml value can be split. Therefore, the delta E that we get, that there are like change in the energy level, that is the because of this additional line. So we need to see what are this delta E between this E, because this E is this line is always present. So this is the main level. Then what are this additional levels? So what is the energy level difference here? Then we put the values and we get delta E equals to ml into mu v into v. So here we only understand that if we get different ml values for a particular L, then we should get particular delta E shift. Like there should be that many lines will be present. Let's say ml equals to L equals to 2. So how many ml values? Minus 2 to plus 2. Let's say L equals to 3. How many ml values? Minus 3 to plus 3. Let's say ml equals to 1. How many L equals to 1. How many ml values? Minus 1 to plus 1. So we should get that much energy level if we have delta E, and this is the key concept for ml. तो जो आपका डाउट था कि कब कितना एनर्जी लेवल में स्प्लिटिंग होगा, वो कंफ्यूजन अभी आपका आई होप खत्म हो गया, क्योंकि आप यहाँ से डिसाइड कर सकते हो कि डेल्टा ई कैसे हमें कितना लाइन्स मिलेगी. ठीक है.
यस मैम.
नेक्स्ट अब बात करते हैं एनामोलस इफेक्ट की. तो फर्स्ट थिंग कि नॉर्मल में मैग्नेटिक फील्ड थोड़ा हायर था, लाइक इट वाज लाइक ऑफ द ऑर्डर ऑफ मेनी टेस्ला. तो जहाँ पे आपका स्पिन इफेक्ट जो है उतना प्रोमिनेंट नहीं था. ऑर्बिटल लाइक mu n directly couples with the b and we get ml. So this is the key concept. And we ignore the fact because the coupling between mu l or the mu orbital of the electron with the b, that means external magnetic field, was so strong that we could not observe the coupling of the spin effect or spin magnetic moment with the external magnetic field. Next, we decrease the magnetic field and we observe actually we get more lines. And then if we get more lines, mean there are more splitting. And these many lines are coming from what? That we don't know. And then suddenly we understand that from the standard like experiment that there are spins also present, not only orbital angular momentum. So electron has associated spin angular momentum. So to understand the lines or extra lines occurring in the Zeeman effect, or when the magnetic field is less compared to the normal Zeeman effect, we have to consider the spin magnetic moment of the electron. So because spin it is also like spin has this magnetic moment, so it should also contribute to the Zeeman effect, and this effect is known as anomalous Zeeman effect. And what we should do here, so if we compare these two things, let's say for here we consider only the Lz values for the potential energy, because we have only thought of the mu of orbital, that is the orbital magnetic moment associated with the electron, and it directly associated with L value. And now, what is the difference? Since we have also spin magnetic moment, so we have associated this delta E with E by twice and L plus 2s dot B. So this 2 is given like taken for this like my calculations and degeneracy. And what is the main thing here? That instead of mu L, we are taking different quantity, that is ml, we are taking mj. And this j is considered for both L and S. Like it is taking angular or vital angular momentum as well as spin angular momentum. Therefore, mj values will be the dominant factor to decide the number of lines or number of splittings. So currently, previously we had mu ml value that was the deciding factor because mu v and v are constant. And right now we have this mj value that is the deciding factor where we have to consider L and S value. So, and GL, mu v and v, these are constants. So this way we will get more lines because we are taking more energy levels, one splitted from the mu L and another splitted from the US. So this combination is giving us total mu j or mj values. That's why we get more values. Okay?
Yes, ma'am.
तो ये नॉर्मल जीवन इफेक्ट है. यहाँ पे आप देखो टेस्ला 1 टेस्ला के 90 फील्ड का ऑर्डर लिया है. और फिर एनामोलर जीवन इफेक्ट से अगर हम देखें तो उसमें और कम ऑर्डर के मैग्नेटिक फील्ड हम लेंगे तो वही जो सोडियम डबलेट अगर पहले नॉर्मल जीवन इफेक्ट में हमें 3 लाइन्स मिल रही थी, तो जैसे ही हमने एनामोलर जीवन इफेक्ट ऑब्जर्व किया तो वहाँ हमें सोडियम डबलेट से 4 लाइन्स मिल रही है और फील्ड ऑफ और फील्ड ऑन होने से यहाँ पे हमें 3 लाइन्स मिल रही है. और वैसे ही जिंक में भी आप देखो फील्ड ऑफ है तो सिंगल लाइन मिल रहा है और फील्ड ऑन है तो हमें एक ही सिंगल लाइन की जगह हमें मल्टीपल्स डेल्टा ई ऑफ एनर्जी लेवल इक्वली स्पेस्ड एनर्जी लेवल्स मल्टीपल्स मिल रही है. और वो डिपेंड करेगा हमारे म्यू जे और एम जे वैल्यूज के ऊपर. पर एम जे इज L and S. You have to consider both. And this is the electronic spin. So they can ask you how much electronic spin you have. So you can say this is the magnetic moment. This is the orbital spin momentum of electron, and this is the orbital magnetic moment of the electron, and this is the spin magnetic moment of the electron. And this is associated with the L values, and this is associated with the S values. So that was the basic. अगर हम देखें ज़ीमान इफेक्ट का कहाँ हम एप्लीकेशन कहाँ मिलता है ज़्यादातर. आप अगर एस्ट्रोफिजिक्स का स्पेक्ट्रल लाइन्स अगर स्टडी करोगे एस्ट्रो ऑब्जेक्ट्स का तो उनमें मैग्नेटिक फील्ड्स होती है. तो वहाँ पे जो ट्रांजिशन होगी वहाँ आपको जीवन स्प्लिटिंग मिलना एनामोलस और नॉर्मल लाइक इट इज वेरी कॉमन. तो दिस इज द क्वांटम मैकेनिकली आप परटर्बेशन थ्योरी से ज़ीमान इफेक्ट को एक्सप्लेन कर सकते हो. यहाँ पे spin orbit coupling. This is the major factor for anomalous effect because why we are considering L and S both because of this spin orbit interaction, spin orbit coupling, and that's why we get this L dot J and S dot J and L dot S values when we think of anomalous effect. And so if we make very strong magnetic field, then instead of this spin orbit coupling, they decouple from each other and they individually couple with the external magnetic field. So therefore, now you have like two different, instead of MJ, you will consider ML plus GSMS. So they are not coupled. So MJ was because of the whole coupling, we take one single quantity. But if they decouple with each other, and then we have to consider both values of ML independently with the interaction of the and ms independently with the interaction of. So this is named as Paschen-Back effect, and we get this kind of lines. Okay, so for this astrophysics, Zeeman effect is very important because from that splitting lines, the beauty of Zeeman effect that we can calculate delta E, the energy spacing between the lines. That means that directly gives you some properties, some additional information of these values of the energy levels and also mu V, mu L. So you can identify the atoms. And also it is important for laser cooling, spintronics effect, metrology, like I told you, like we can get the atomic values. Therefore, high precision, if we need to make atomic clocks, which should have like high precision frequency standard, then we can finely tune with delta E using the Zeeman effect. We can finely tune clocks, atomic clocks, and also nuclear Zeeman effect. Similar like electronic Zeeman effect. And this is a demonstration. So if you have like a sodium vapor lamp, if you want to check the sodium doublet lines, so you have the sodium atom and you have electricity, and you off it and you record in a screen the spectrum, and then you switch on the vapor lamp and you switch on the voltage, and we will get the illumination. So, serial effect demonstration. Is there any doubt in this topic?
No, ma'am.
Okay. And I can start the class. Is there any doubt from the previous class?
No, ma'am.
So this we will discuss about very basic of postulates of quantum mechanics. So we just talk about some basics of before coming to Schrodinger equation. We know we have several postulates to understand what is quantum mechanics and how do you formulate the mechanics, because for mechanics we have to understand what should be the coordinate, what is the geometry, what should be the like uh, which space we should quantify these geometries. Because if you talk about Newtonian mechanics, we have to, like, let's say we have to assign some position or some position vector with an object, and then also we think this object is a three-dimensional Cartesian coordinate. So then we specify the dynamics like velocity, momentum, energy, kinetic energy, potential energy. So these things will be specified. So first we associate something with the particle, and then further we, with the geometry, we understand the dynamics. So similarly, quantum mechanics requires the same kind of mechanics, but this is not just a particle, but this is with the understanding of duality of nature. Particle can be wave or it can be particle. So quantum mechanics acknowledges the wave-particle duality of matter by supposing that rather than traveling along a definite path, a particle is distributed through space like a wave. So now this is like we understand that if we think of some like we have like this kind of philosophy in Mandukya Upanishad. So there is a like asking of that who am I? So am I the one who is talking to you? Am I the one when I am sleeping? Am I the one who is in a deep sleep, or who am I? Because for when I am dreaming something in the sleep, I also think that that is the me when I am like. In fact, I know this is illusion when I from the like I came with that. Okay, that was a sleep and that was a dream. But at that moment, it thought we thought that okay, we are that person. And for that particular moment of the dream, we didn't think that we are separate from that person. And right now, I am talking, so I know I am talking. Or when I am even asleep, I am not dreaming, I am not talking. I know that is me. So who is the actual me? So the similar questions like what is particle? It is wave or it is particle? What is matter? So let's say I can give you an example. So we have a gold and I make a bangle from the gold and I give to my friend. And my friend told me, no, I don't want bangle. I want a necklace. So I took it back to the bangle and I go to jewelry shop and I told the jewelry to make it a necklace. So he made the same thing with he made the necklace with the same gold. And then I gifted her and he took it happily. So what was that gift? It was bangle or it was necklace? It was the gold. The form is only changing. Okay. So similarly, here we can just correlate that the form is changing, but it is not like a wave or not a particle. It is nothing. So for that Upanishad also, it was told by the saint that you are nothing of it. Okay? So don't think like you are when you were speaking you are the person, or when you were dreaming you are that person, or when you were sleeping you are that person. These are only the forms. You were changing at times. So the for similarly matter, we are seeing the original none of it. It is neither particle nor wave. Like of course they are when they are in that form, we can see them, but in reality this is very abstract and it can change the shape. So similarly, like it was the gold that can change the shape of a bangle or it can change the shape of a necklace, depending on how what is the requirement. Okay, so let's come back. So the way uh, that we talk about in quantum mechanics that replaces the classical concept of particles because we know in classically we can have the particle which is deterministic. Of course, it is particle. Of course, it has this. It cannot be wave, but here it is not like that. And so we won't like also correlate with the wave, or we won't correlate with the particle. We will correlate the matter wave as a wave function side. And for that wave function, we have to consider that there are coordinates associated with the wave function. And if you are asked that what is wave function in quantum mechanics describes the quantum state of a system which is isolated of one or more particles. There is one wave function containing all the information about the entire system, not a separate wave function for each particle in the system. So if we are talking about the system, we will consider the quantum function of the system. And if we have an isolated particle, then we will consider the wave function of that isolated particle. And Born interpretation, which is very important in quantum mechanics. So first we know that we have a wave function. And how do you define the system once we have a multi-particles in a system? And how do you define the wave function? Because for a single particle, we know wave function will be a coordinate of r if it is stable, and then r is like associated with the coordinate, Cartesian coordinate, let's say x, y, z. And if it is dynamic, then it will be also assigned with a t value. For a multi-particle system or multiple particles or multiple waves, then we have to decide. Let's say for two particle system, we can write psi as x1, y1, z1, x2, y2, z2, t. So for the whole system, the wave function is different, like this way. So what is the correlation? Wave function for quantum mechanics is similar like classical trajectory in Newtonian mechanics. We are not talking about classical particle in Newtonian mechanics, because this trajectory was important because this wave is not like a single position. It is broad. So let's come back to the postulate one. So once we have this abstract understanding of science, which we don't understand actually, physically, how do you then correlate with the physical thing? Because in this Cartesian geometry, where our visualization is very limited, we can only see x, y, z, and we can understand t. Because our senses are very limited, then how do you understand that everything is like so much of abstract and lot of how do you understand quantum mechanics? So for that purpose, we need some interpretation. And one of the major interpretation is Born interpretation. So the state of a quantum mechanical system is specified by a wave function psi is a function of r and t, where we can write this x, y, z as r and t is the time. So this depends on the coordinate of the particle, which is r, and time t. And these functions are called wave functions or state functions. And if we have this psi, let's say, we can write it as a, like the probability of finding the wave function, we can write as PR, which is mode of psi square. So we are not talking about that we will get psi, but we are talking about the probability of getting psi, which is important to understand the reality, because in reality we will do experiments, we will do measurements. Therefore, we need to understand when we will get the measurement. So that is the interpretation. The probability of the particle can be found at a particular point x and a particular time. That is, P of r can be written as mod of psi square or integration over psi square psi d. And when it is positive, when P of r is greater equals to 0, and if we have like probability and now if we have like probability is 0, then we have like nothing. And if we tell probability greater equals 0, then it could be point, it could be like half, it could be like 1/4. Then what does it mean? It says something. A probability of finding a particle is 1/4. That means that part of the particle will be present here and part of the particle is present in other space. How do you know that? It is not realistic. So therefore, normalization condition is very important. The probability of getting the particle in the or space, like within this space, physical space, should be 1, equals to 1. So the probability of particle in this universe that we can sense and that we can see and that we can measure, that is 1. Now, of course, the wave function, since the probability must be 1, so it should be square integrable. And it should be square integrable. And if we integrate it for the all over the space, minus infinite to plus infinite, it must be equal to 1. Everything till now is okay?
Yes, ma'am.
And next is the continuous first derivative. Because if we talk about the derivative of the whole function, we know the first derivative is like continuous. First, we should talk about continuous wave function. Okay. We talk about the square integrability and we will talk about the wave function continuous. Should be continuous. To be a well-behaved wave. Why it is continuous? if we have two values at the same point because of the discontinuity, then this is not a proper wave function. Because then probability of getting the particle at one point, simultaneously we can get the particle at another point. Therefore, the continuous wave function is very important. And another important factor is that if the wave function is not continuous, at this discontinuity, the first order derivative will be infinite. And particle's momentum is associated with the first order derivative of psi. So if first order derivative is infinite, that means the momentum will be infinite, minus IH plus delta I. So infinite momentum particle means there is no particle. That is not a realistic figure. What we talk? First we say, first well behavior condition of well behavior function, what function is should be continuous. One, and second is the why it is should be because of the if it is discontinuous, then of course we will get first order derivative at the discontinuity point will be infinite. Or, so therefore, or will diverge. So therefore, this first order derivative of the wave function is associated with the momentum. And if momentum diverges or momentum value is infinite, that means the situation is not realistic. The second major condition is continuous first derivative. So if you don't have continuous first derivative, then at this discontinuity point, if you take the second derivative, then you will get that this discontinuity for the first derivative will make a problem, and you will get divergent second derivative or infinite second derivative. And now the second derivative, L2 psi del T2, is directly related with the energy. So particles have infinite energy. That is not physically realistic. So discontinuous first derivative would imply an infinite second derivative, and since the energy of the system is found using a second derivative, discontinuous first derivative would imply an infinite energy, which is again not feasible or not realistic. So therefore, we should have continuous first derivative. And see this is acceptable or not. What do you think here? The first,
No, ma'am.
why it is not?
बिकॉज मैम वेव फंक्शन एक सिंगल वैल्यू नहीं दे रहा है, मल्टीपल वैल्यूज है, तो प्रोबेबिलिटी की भी मल्टीपल वैल्यूज हो जाएंगी, जो कि पॉसिबल नहीं होता है.
Second one, is this acceptable?
मैम ये बीच में से कटिंग है या ये मेरे को शो हो रही है?
Cutting it.
फिर तो नहीं होगा मैम, क्योंकि वेव फंक्शन कंटिन्यूस नहीं है ना, ब्रेक हो रहा है.
This one, hard.
ये भी नहीं होगा मैम, कंटिन्यूस नहीं है.
Divergent, है ना?
हाँ जी.
और ये fourth,
No, ma'am.
no.
मैम डिफरेंशिएबल नहीं है इस टर्निंग पॉइंट पे.
ये इनमें से कौन सा एक्सेप्टेबल है, कौन सा नॉट एक्सेप्टेबल है, ये आप ड्राइव करके दिखाओ. मतलब क्यों नहीं है तो क्यों है. This solve this problem. Out of 4, which one is acceptable, which one is not. And you have to also Consider the conditions. Real valued, continuous, first derivative, second derivative, square integratability, everything. And send me in the WhatsApp group. ठीक है, क्वेश्चन समझ में आ गया?
Yes, ma'am.